The important types of measurement of angle you are going to study in this session is Sexagesimal measure and the radian or circular measure. X degree is equal to pi x divided by 180 radians. Now let us move on to the first one. 25 degrees. 25 degree can be done as 25 into pi by 180. 3k plus 4k plus 5k. Sum of three angles is equal to 180 degree. 180 degree means that's equal to pi radians. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take very important chapter, that is chapter number 13, angles and trigonometric ratios. So in trigonometry you are going to study two chapters. The first chapter is angles and trigonometric ratio. This is very important chapter. In general, in total for trigonometry you will get 15 marks. So this chapter is for 9 marks and one more chapter, trigonometrical ratios of standard angles, that is for 6 marks. Totally from this unit trigonometry you are going to get 15 marks. Now let us discuss regarding the angles and trigonometrical ratios in the chapter, first chapter of trigonometry. Now angles and trigonometrical ratio. Now, what is this trigonometry? Before going to the exact, let us know regarding trigonometry. You might have been studied trigonometry in your previous classes. Let me recall what is trigonometry. The word trigonometry, the trigonometry is divided into three parts, that is tri, then gno and metry. That is trigonometry. So, which in Greek means tri means three. Which in Greek, tri, gno and metry means, tri means 3, gno means angles and metry means measurement. So, 3 angle measurement, measurement of a triangle. So, trigonometry is divided into 3 parts, tri, that is 3, gno angles, metry means measurements, 3 angle measurement, measurement of a triangle. Now, primarily the subject deals with the relation between the sides and angles and area of a triangle. But the trigonometry has much wider scope and used in geometrical and algebraic investigation in pure as well as in applied mathematics. So this subject was mainly developed to solve the problems in astronomy, that is regarding just to study regarding the study of heavenly object, the distance between the two planets, or to find the distance between any two planets. We are going to use the concept of this trigonometry. Now let us know regarding the mathematicians, like so many mathematicians has given contribution for the development of this trigonometry. So main important, Hippocrates, a Greek astronomer, is known as founder of trigonometry, and other who contributed to this branch includes Euler, John Bernoulli, Fourier and Gauss. So they have given more contribution for the development of this chapter, this unit trigonometry. Hippocrates is a man, he is a Greek mathematician who has given more contribution for the development of this trigonometry. The foremost Indian mathematicians who have also, like Bhaskaracharya, Brahmaputra, they have also contributed for the development of this trigonometry. The Indian mathematicians who have worked on this branch of mathematics are Aryabhatta, Brahmagupta and Bhaskaracharya. The Indian mathematicians also given more contribution for the development of this unit trigonometry. So the mathematicians like Aryabhatta, Brahmagupta and Bhaskaracharya from India, they have also given more contribution for the development of this trigonometry. Now, nowadays we are using all this trigonometry in almost all fields of science and engineering. Now, angles and measurement. Now, let us know regarding an angle. What is an angle? When did you say an angle is said to be generated? That means, when a line revolves about a point O from the one position P to another position Q, we say an angle is said to be generated. An angle is formed and this angle is denoted as angle POQ. The point O is called the vertex of an angle. So here, when a line revolves about the point O from the position, this is the point O. So if it revolves, this is OP. If it revolves in this direction, then this is Q, an angle POQ is said to be generated, an angle POQ is said to be generated, and this is denoted as angle theta. Theta is an angle theta is said to be generated. So here O is called, the point O is called as the vertex of the angle POQ. O is the vertex of an angle. So that means if any line, if an initial line fills in any direction like this, an angle is said to be generated. If it is in this direction, an angle is said to be generated, that is a negative angle, positive and a negative angle. Now, by knowing this angle, now the question arises, how to measure this an angle? There are different types of measurement of an angle. So, the important types of measurement of angle you are going to study in this session is Sexagesimal measure and the radian or circular measure. Sexagesimal measure, centesimal measure and a radian or a circular measure. Now, let us know regarding Sexagesimal measure. In this measure, one right angle, the angle between an horizontal line and the vertical plumb line is called a right angle, and one right angle is divided into 90 equal parts and each part is called a degree. Again further 1 degree is divided into 60 equal parts and each part is called a minute. Again further 1 minute is divided into 60 equal parts and each part is called a second. So, in this type of measurement, one right angle is equal to 90 degree and 1 degree is equal to 60 minute and 1 minute is equal to 60 seconds. So, in this system we divide right angle into 90 equal parts and this part is called as the degree. So, each part is called degree and it is denoted as 1 degree. So, one right angle is divided into 90 equal parts and each part is called a degree. One right angle is equal to 90 degree. Then we divide 1 degree into 60 equal parts and each part is called as a minute, 1 minute. So, 1 degree is divided into 60 equal parts and each part is called a minute, 1 minute. 1 degree is equal to 60 minute. Again, 1 minute is again divided into 60 equal parts and each part is called as second. So, therefore, 1 minute is equal to 60 seconds. So, thus in this measurement, one right angle is equal to 90 degree, 1 degree is equal to 60 minute and again 1 minute is equal to 60 seconds. So, hence in this sexagesimal measurement, so we divide an angle into degrees and one right angle is equal to 90 degree, again degrees into minutes and minutes into seconds. So, in this measurement, one right angle is equal to 90 degrees. One right angle is equal to 90 degree. Again, 1 degree is divided into 60 equal parts. Each part is called a minute. So, 1 degree is equal to 60 minute and 1 minute is divided into 60 equal parts. Each part is called as a second. So, one right angle is equal to 90 degree, 1 degree is equal to 60 minute and 1 minute is equal to 60 seconds. Right. Now, let us move on to the next second measurement, that is called as the circular system or radian measure. This is very important concept, radian measure or circular measure. So, in this system we call the unit of measurement of an angle as radian. So, the unit of measurement of an angle as a radian and the measure of this angle as radian measure, or it is also called as the circular measure. So, what is this radian? A radian is nothing but an angle subtended at the center of a circle by an arc and two radii. The angle subtended at the center of a circle by an arc and two radii is called a radian. Now, what is one radian here? So, a radian is an angle subtended at the center of the circle by an arc length whose length is equal to radius of the circle. If the length of the arc is equal to length of this radius, if arc length and radius are same, then an angle is said to be generated. That angle is equal to 1 radian or 1 circular measure. So, here angle AOB is equal to 1C, 1 circular measure. Angle AOB is equal to 1 circular measure. This is angle AOB is equal to 1 radian or it is nothing but 1 circular measure and denoted as 1C, 1 radian. So, a radian is nothing, 1 radian means an angle subtended at the center of a circle by an arc equal to the radius. If arc length and the radius are same, so if OA, radius OA is equal to R and the arc AB is also equal to R, then the angle AOB is said to be 1 radian or 1 circular measure. So 1 radian, how to define 1 radian? The angle subtended at the center of a circle by an arc equal to the radius, then the angle AOB is called 1 radian or 1 circular measure. Let us come to the next concept. Now this is very important theorem. Prove that radian is a constant angle. Radian is a constant angle, and to prove that pi radians is always equal to 180 degrees. Pi radians is always equal to 180 degrees. Radian is a constant angle and pi radians is equal to 180 degrees. Let us derive. This is very important theorem. Now, let us consider a circle. Let us consider a circle with O as center and R is the radius. Mark the point A and B on the circle such that angle AOB is equal to 1 radian or 1 circular measure. So, consider a circle with O as center and R is the radius, that is OA is equal to OB is equal to R. Mark the point, so B on the circle such that angle AOB is equal to 1 radians. Now, produce AO to cut the circle at C. Then, OC is also equal to the radius R. This is the construction part. So, that is, consider a circle with O as center and R is the radius. Let AB is an arc of length S, R, S is the S or R is the arc length. Then angle AOB is equal to 1 radian. Produce AO to cut the circle at C. Then OC is also equal to the radius R. Now we know that the angles at the center of a circle are proportional to the arc on which they stand. Now according to this condition, that is, the angles at the centers of a circle are proportional to the arcs on which they stand. Now from this, angle AOB divided by angle AOC, see here, angle AOB divided by angle AOC is equal to, therefore angle AOB divided by angle AOC is equal to, what is this equal to? Just write down the arcs on which they depend. Okay, so that's equal to arc AB divided by arc ABC. That's it. See here, angle AOB is nothing but arc AB and angle AOC, for AOC the arc AC. So angle AOB by angle AOC is equal to arc AB divided by arc ABC. Substitute here. Just I will go to the next page. Therefore, angle AOB divided by angle AOC is equal to arc AB divided by arc ABC. Okay. Now, what is arc ABC from this? This arc ABC is nothing but half of the circumference of the circle. Arc ABC is equal to half of circumference of the circles. What is the circumference of circle? 2 pi r. So that's equal to pi r. That's it. Right. Now substitute here. What is angle AOB? Angle AOB is equal to 1 radian divided by angle AOC. What is AOC is equal to? So angle AOC, this is AOC is nothing but 190 degrees, straight line 190 degrees. Angle AOC is equal to 180 divided by arc AB. This arc AB is equal to R divided by arc ABC is equal to pi r. R divided by arc of ABC is nothing but pi into R. So this R and R gets cancelled. 1 radian by 180 degrees is equal to 1 by pi. Cross multiply. 1 radian into pi is equal to 180 degree into 1. So therefore you can write 1 radian into pi is pi radians is equal to 180 degrees. Pi radians is equal to 180 degree. That's it. Hope you followed. Angle AOB by angle AOC is equal to arc AB by arc ABC. Angle AOB is equal to 1 radian and angle AOC is equal to 180 degrees. Arc AB is nothing but R divided by arc of ABC is pi r. R and R gets cancelled. 1 radian by 180 degrees is equal to 1 by pi. Cross multiplied. 1 radian into pi is equal to 180 degree into 1. So pi radians is equal to 180 degrees. So therefore pi radians is always equal to 180. That is, radians is a constant angle and pi radians is always equal to 180 degrees. So in trigonometry, for pi we are going to use 180 degrees. Right. So therefore, for 1 degree, we are going to use pi by 180 radians. That's it. Now, let's move on to very important concept from this derivation. What is the conclusion? Pi radians is equal to 180 degree and 1 degree is equal to pi by 180 radians. So, radians is a constant angle and pi radians is always equal to 180 degree. So, we can use this formula to convert radians into degrees and degrees into radians. So, from degrees to radians, multiply the given angle by pi by 8. To convert radians into degrees, multiply the angle by 180 by pi. So, therefore, to convert degrees into radians, we are going to use x degree is equal to pi x divided by 180 radians. X degree is equal to pi x by 180 radians, or x radians is equal to 180 pi into x degrees. This is the formula. So, to from degrees to radians, multiply by pi by 180, and to convert radians into degree, multiply by 180 by x. So, therefore, this is very important formula. X degree, to convert degrees into radians, x degree is equal to pi x divided by 180 radians, and x radians is equal to pi 180 into 180 by pi into x. Now, by knowing this, move on to the problems. Let us take very important problems. You may expect one more question from this. Convert the following angle measured in degrees into radians. So, we are just convert degrees into radians. Convert the following degrees into radians. To convert degrees into radians, what is the formula we are going to use? So, that is x degree is equal to pi x divided by 180 radians. Now, let us move on to the first one. 25 degrees. 25 degree can be done as 25 into pi by 180. Let us divide by 5. 5 5s are 25. Again from 5. 5 3s are 15. And what is remaining is 30. 5 6s are 30. That's equal to 5 pi by 36. That's it. So, 5 pi by 36 is nothing but 25 degrees. Okay. Next, 95 degrees. 95 degrees can be done as 95 into pi by 180. Simplify this. Now, let us divide by 5. So, 5 19s are 5 36 are. So, 19 pi by 36. So, if it possible to divide, again divide it. Now, move on to the next one. 105 degrees. 105 degrees is equal to 105 into pi by 180. Divide it. So, you can divide from 5. So, 5 2s are and 5 1s are. Again this 5 36 are. 21 pi divided by 36. If it is possible to divide, again you can divide it. You can divide from 3. 3 7s are, 3 1s are, 3 2s are. 7 pi by 12. That's it. Okay. So, this is equal to 7 pi by 12. Now, move on to the next one. Convert 135 degrees. 135 degrees can be written as 135 is equal to 135 into pi by 180. So, this can be divisible by 45. 45 3s are, 45 4s are. This is 3 pi by 4. Right. Now, next is 210 degree. 210 degree can be written as 210 into pi by 180. 210 divided by 180 degrees. This 0 and 0 gets cancelled. 21 pi divided by 18. You can divide by 3. 3 7s are, 3 6 are. 7 pi by 6. That's it. 7 pi by 6 radians. That's it. This is how we are going to convert the degrees into radians. For example, if you want to convert, yes, if you want to convert 720 degree. 720 degrees is equal to 720 into pi by 180. That's 0 0 gets cancelled. 72 pi divided by 18. Divide it. So, you can divide by 2. If you divide by 2, 2 3s are 6, 2 6s are 12 divided by, again 2 9s are 18. 36 pi by 9. Again, if you divide by 3, 3 3s are, 3 1s are, 3 2s are. So, that's equal to 12 pi by 3. Again, this is equal to 4 pi. That's equal to 4 pi. 720 is equal to 4 pi. Right. What is pi? 180. 180 into 4 is 720. Now move on to the next one. 18 degrees. 18 degrees can be written as 18 into pi by 180. So this is 18 tens are. That's equal to pi by 10 radians. That's it. Now let us come to the last one. 36 degrees. 36 degrees is equal to 36 into pi by 180. Straight away you can divide. 36 5s are. This is equal to 5 by 5. That's it. 36 5s are 180. 36 into pi by 180 is equal to pi by 5. That's it. So this is how we are going to convert. For example, 30 degrees can be written as pi by 6. For example, 45 degrees, pi by 4. For example, 60 degrees, this is equal to pi by 3. For 90 degrees, we are going to represent it as pi by 2. Right. These are few standard angles. Now move on to the next concept. Convert the following angle measured in degrees into radians. So the angle measured in degrees is converted into radians. Again 144 degrees. Now 144 degrees can be written as 144 into pi by 180. What is this equal to? Now let us divide this. 144. So divide from 12 12s are, 12 1s are, 12 5s are. That is 12 pi by 15. Again you can divide from, so from 3 4s are, 3 5s are. That is equal to 4 pi by 5. 4 pi by 5. So 144 degrees is equal to 4 pi by 5. And the last one, 90 degrees. 90 into pi by 180. 0 gets cancelled. 9 2s are. This is equal to pi by 2 radians. That's it. 90 degrees is equal to pi by 2 radians. Hope you followed. Now, express the following sexagesimal measure in degrees. That is, express the following radians into degrees. Express the following radians into degrees. Now to convert radians into degrees, x radians is equal to 180x divided by pi degrees. This is the formula we are going to use. Now let us convert this. First one, 7 pi by 3 is equal to 7 pi by 3 into 180 divided by pi. Pi and pi gets cancelled. 3 6 are 60. 7 into 60. 7 into 60 degree. 420 degrees. That's it. 7 pi by 3 is equal to 420. Now, next, 17 pi by 9. This is equal to 17 pi by 9 into 180 divided by pi. Pi and pi gets cancelled. 9 2s are 20 degrees. 17 into 20 degrees. 17 into 20 is 340 degrees. This is equal to 340 degrees. That's it. Okay. So, this is how we are going to convert radians into degrees. So, to convert radians into degrees, what is the formula? X radians is equal to 180x divided by pi degrees. Now, move on to the next problem. 7 pi by 8. 7 pi by 8 can be written as 7 pi by 8 into, what is the formula? 180 by pi. Pi and pi gets cancelled. Divide this. 7 into 180 divided by 8. So, this is equal to 7 into 180 divided by 2 is 22.5 degrees. That's equal to 157.5 degrees. 157.5 degrees. Okay. Next, pi by 24. Pi by 24 into 180 divided by pi. This gets cancelled. 180 divided by 24. What is this equal to? This is equal to 7.5 degrees. Okay. Now, move on to the next problem. Same. Express the following radians into degrees. 9 pi by 5. That is 9 pi by 5 into 180 divided by pi. So, express radians into degrees. So, this gets cancelled. That's equal to 9 into 180 degrees divided by 5. So, what is this equal to? 180 by 5. So if you divide 180 by 5, you will get 36. 9 into 36 degrees is equal to 324 degrees. 324. Now move on to the next one. 2 pi by 12. 2 pi by 12 into 180 divided by pi. Pi gets cancelled. 2 6 are, that is nothing but 180 degree divided by 6. 6 3s are, that's equal to 30 degrees. That's it. This is nothing but 2 pi by 12 is also equal to pi by 6. Pi by 6 is nothing but 30 degrees. That's it. Now, move on to the next problem. Same, convert the following degrees, radians into degrees. Radians into degrees. Now, 3 pi by 5 is equal to 180 divided by pi. Now, this gets cancelled. 3 into 180 divided by 5. What is this equal to? 180 by 5 is 36. 3 into 36. 3 into 36 is equal to 108 degrees. Now, similarly 2 pi. 2 pi into 180 divided by pi. Pi gets cancelled. 2 into 180 degree. That's equal to 360 degrees. Right. So, this is how we are going to convert degrees into radians and radians into degrees. Hope you got an idea. Now, let us come to the next set of problems. Find the angles of a triangle in ratio 3:4:5. Find, yes, if the angles of a triangle are in the ratio 3:4:5, find them in radians and in degrees. Now, let us consider, let the angles of the triangle be, let the angles of triangle, the angle of triangle B, let us consider the angles as 3K, 4K and 5K. Now, first condition, find them in radians. Radians 3K plus 4K plus 5K. Sum of three angles is equal to 180 degree. 180 degree means that's equal to pi radians. So, 5 plus 4, 9, 9 plus 3 is 12K is equal to pi, therefore, K is equal to pi by 12. So, therefore, in radians, A is equal to 3 times K, 3 into pi by 12, that is nothing but 3 4s are, this is pi by 4. Angle B is equal to 4K, 4 into pi by 12, 4 3s are, this is equal to pi by 3, and angle C is equal to 5K. 5K means 5 into pi by 12. So, that's equal to 5 pi by 12. So, these are the angles, pi by 4, pi by 3 and 5 pi by 12. Okay. Now, the second part. What is the second part? Express them in degrees. So, in degrees, sum of three angles A plus B plus C is equal to 180 degrees. What is A plus B plus C? That is 3K plus 4K plus 5K is equal to 180 degrees. 5 plus 4, 9 plus 3 is 12K is equal to 180 degrees. Therefore, K is equal to 180 divided by 12. 180 divided by 12. Okay. 180 divided by 12 is equal to 15 degrees. Now, therefore, A is equal to, what is A? 3K. 3 into 15, that's equal to 45 degrees. And what is B? B is equal to 4K. 4 into 15, that's equal to 60 degrees. And C is equal to 5K. 5 into 15 degrees. 5 into 15, that's equal to 75 degrees. See, if you add 5 plus 5, 10, 6 plus 4, 10 plus 1, 11 plus 7 is 180 degrees. So, pi by 4 means 45 degrees, pi by 3 means 60 degrees, and 5 pi by 12 is equal to 75 degrees. That's it. This is how we are going to express the ratios in terms of angles as well as in terms of degrees. So, pi by 4, pi by 3, 7 pi by 2 in terms of radians, whereas in terms of degrees it is 45 degrees, 60 degrees and 75 degrees. That's it. Hope you followed. Okay. So, this is how we are going to convert the angles in ratios as degrees and radians. This is also an important problem for 2 or 3 marks. Hope you followed. That's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you. Thank you very much.